Remember to put this on airplane mode. Yeah.
Just like this, or
Did it say? I think all it said was factor. Yeah. What was this? There it is. Yeah, that's it. Factor each expression completely. So
let's say there's an extra step where we should do it.
it might be equal to 0, and then you just solve that. Yeah. Yeah.
I'm still a little fuzzy on multiplying exponents with my fractions. Go over that really quickly. Because you took them out, so I wouldn't know how they go back in.
Well, what do you do with powers when you multiply? When you're multiplying things with powers, you add the powers. So 2 minus a half is 3 halves, so forth. Yeah. So that's how you can kind of double check yourself at the end. Yeah. Anything else from? Yeah. 18? And by the way, don't freak. As soon as it seems that there's not many Chapter 1 questions left, we're going to take a break, and then we'll get into Chapter 2. So normally, I give you guys at least like a 15-minute break, since this is a 3-hour class. It's hard to keep going, yeah. So which one, sorry? 8E? Oh, yeah. Sounds familiar. Yeah. So, what was that? Somebody's flight stick. So, the very first step, this square root doesn't really even matter. I get the square root of stuff equals 2. And in here, the stuff is what has my variable in it. So I just want to strip that square root away so I can get at it. So I shouldn't even let the fact that there's another square root in there bother me at first. I don't care. I got to get this dude the hell out of the way. So I square both sides. So that square just cancels with that big ass square root. It does not somehow magically kill this one also. And I definitely do not want to do this next. What would your intention be for doing this? To get rid of the radical. It would not accomplish that. Not only would it not accomplish that, it would bring in a lot of extra stuff I didn't have. Right? So I can't, when I square this, I have to FOIL it. I can't just say 9 minus x plus 5. I'd have to FOIL it, and the middle term still has the radical. Yeah. So you always isolate your radical element. Right? You're the tyrant in charge of your country, and you have a radical element. You isolate them and you kill them. So here I have to subtract the 3. And then, yeah. Now hopefully right there you realize this is not going anywhere. The square root of a number cannot be -1. As far as we know. But if you didn't realize that and you kept going, you seemingly get an answer. But if you try to plug it in, it doesn't work. So anytime you have an equation that starts with radical square roots, you must check your solutions, because along the way, whenever you square, and this is exactly showing you, whenever you square both sides of an equation, you lose information about the sign. It was negative, now it's 1. So when I look at this equation, if I just said, there's an equation, what was before it, you're like, I have no freaking clue, man. If I tell you I squared something, what was here? Was it a 1 or a -1? They both would get here. So it's lost information about what sign it had. So I can't trust this answer. But right here, before you square, you should realize there's no solution. You want to get really, I say no real solution that you know. Yeah. Say again? All right, so if I wanted to check it, negative square root of x plus 5 equals 1. Or even put it in here. So the square root of Negative 4 plus 5 is the square root of 1, which is 1, not negative. Cool. That's what I mean about it lost information about the sign.
So where are we stopping?
And it should be at the beginning, but to tell you honestly, if an answer doesn't work in the middle step, it probably doesn't work in the beginning. But you're right, you should always plug it back in here. Yeah.
Can you like use imaginary numbers for that one?
Imaginary numbers are kind of the reverse of this. Imaginary numbers say if I take a square root of a negative number, I can write it as a complex or imaginary number. This is taking a square root of a number and getting a negative answer. And to tell you honestly, this symbol already implies that they want the positive root of something. They'd have to put the negative sign on it to imply they want the negative root of something. Yeah. Does that make sense? I mean, so it's sort of not, it's the opposite situation from a complex answer. Complex answer is about taking roots of negatives. This is a question about having a root equal a negative.
Okay.
Okay, cool.
You plug in the negative 4 in the beginning, is that correct?
If you plug in negative 4, you get negative 4 plus 5 is 1. Square root of 1 is 1. 3 minus 1 is 2. The square root of 2 is not 2. Yeah. So real quick, I want you to realize something. If you do plug it in the very beginning, you get... Now, if only that would have been... What would make this true? If that would have been plus. So it's all about losing information about the signs of things. So if only that would have been a plus, it would have worked. And that negative actually gets lost right on this step. So math says, oh, sweet, there you go. And then we go, oh, shit, there was a negative there. I didn't know that. So when I teach my Math 90 students this, and they already hate math with a passion, most of them, and then they see math has given them an answer that doesn't work. Like, everything right and it doesn't work. So, but I try to tell them, it's not fair to math. You did something that changed the equation in a way that it lost information about what it used to be. That's not fair. So math said, and for this, that's the answer, but when you try to go all the way back, you lost that minus sign. And we can see that right here. If only that was a plus, it would be fine. But it isn't. So it's no good. Okay, cool. Yeah?
15. With 15 from the chapter test, I had trouble finding the area after I got.
Oh, yeah. That was another one I thought I might get a question about. Here, in a few minutes we'll have this done. Let's see. 15. So what is it? 0, 3, and 3, 0, right? Where do you go? P is 0, 3. Q is 3, 0. R is 6, 3. So, and this has to make a square, right?
It's going to be a curve square, like wherever side is.
Yeah, it's going to be a diamond. Yeah. Okay. So considering the fact that we know it's a diamond, holy crap.
You got
know
in your
it.
head.
Wow.
Square.
That is a curve square.
So grades your stuff.
You know my name.
I'm a horrible artist, I'll tell you that. I don't think you can even call this anywhere near being an artist. What's got to be true about that diagonal, this distance here? Pretend like it's correctly across. All right. Picture's not beautiful, but gets the idea across. The quick way to find where this last point has to go is to go straight up from here. How far? Well, how far away is this to the midline?
Twice the distance.
3 away. So how far past that? 3 away. So there's the last point there.
3 plus
And what point is that?
3 plus 6.
Yes.
Yeah, 3, 6. Which is sort of the inverse of 3. And that's the inverse of that. Okay. How we doing? Somebody decent? So that's the first part. And of course, whoever asked the question, you're like, I had no problem with that too. The next part is what's the area of this thing? And there's a few different ways. Oh my God. There's a few different ways to, even when I have a scale, I can. So you have the area of this.
X1 plus x2 and the whole square. That's square.
3 over 3.
Yeah, you can use the triangles if you want to.
6,
Right.
6 divided by 2.
Where are we at? Yeah, because if you realize that if you just rotate this, it all depends on the distance here, right? So I mean, you can either figure out what this is using some Pythagorean theorem. You might realize that since this is a square, it involves the 45-degree angle. I don't know if you guys should have learned from geometry about what the diagonal would be in that situation. I mean, there's a lot of really hard ways to do this. I don't know why you would do that to yourself. If I look at this little piece here, it's the first thing I would think of. It's this little piece here. If I find that area, it's the same as that area, right? And that area is 3, and then I just have to multiply by 4, right? Because there's 4. I mean, but any way that you come up with should probably be okay. One way is just to find the distance here, and then square it, right? And how do you find the distance between 6, 3 and 3, 0? The distance formula, square root of 6 minus 3 squared plus 3 squared, so forth. Some of you guys might realize that's what I was talking about just a second ago with the 45-degree angle. Of course, you might not. If I have a triangle like that, 1, 1, this is going to be root 2. So if I have a triangle 3, 3, this is going to be 3 root 2. Triple that, that's all it is. So this will be, what is it, 3 root 2, like I just said. And then you just got to square that bad boy, right? So if you do it that way, the area is 3 root 2 squared. 9 times 2 is 18. If you do it this way, the area of this triangle is 1/2 3 times 3. So 1/2 times 9. So if you take 9 halves multiplied by 4, get 18? Right, of course. So there's a few different ways to get that area. And of course, there's more than that. There's probably could be easier ways than that, but that's just the first thing that came to mind. Are you guys decent with one of those ways somewhere? You don't have to fool me. You be honest. Yeah. Let's see. So this is your classic example of what situation? Yeah, cross multiplying. So students very often they want to cross multiply everywhere, and technically there's only one place you can truly cross multiply a fraction equals a fraction. There are a few places you can use cross multiplication in a clever way, modify it a little bit, but this is the only place you can do it directly. So we gotta get 2x squared, and then I gotta FOIL that out. Plus 2x minus x. So that becomes really nice, right? 2x squares go away. Yeah, so you get x equals 1.
We didn't have to do that.
That's right. Yeah.
Yeah. Are we supposed to do the calculations, crossing out sideways, what's the side is equal to? I mean, we're only allowed to do it once the side.
No. If you cross something out, you're implying to me that there are two operations that are the opposite of each other. Let me say it again. If you cancel something, you're telling me that there are two operations in there that are the opposite of each other. So if it was this, then it can cross cancel. Because division is the opposite of multiplication. Equals is not an operation. So I can't, I don't know if you guys are talking about killing the x.
So what did you do? Did you cancel it out or you multiply?
Cross multiply.
Cross.
And just to make sure everybody understands this, cross multiplication is a shortcut of the more general property, where I would multiply this side by x plus 1, right, to kill it. So it dies here, and it shows up there. Here I multiply by x. So it dies here and shows up there. So the shortcut is, we'll just take them up there. So it's a shortcut of multiplying by the LCD. This is not its own thing. It's actually just a shortcut of some more general property. Yeah. So I'll tell you what, I'm going to do this problem, and then I'm going to take a break. Because I need one, and if you need one, you'll take one. And then we might take a couple more questions, and then I want to get into chapter 2. Right? Plus. Okay. So can I do something in the process of this problem where I kill the denominators? People say sure. Can I do something in the process of this problem where I kill the denominators?
Take the common.
Good. The correct answer is no. This is not an equation. I don't have two sides to balance out something like multiplying to kill. I don't. So all I can do is find the LCD. These are just fractions, so I have to find the LCD and put them together. I can't lose my denominator on the way. That's wishful thinking. So, of course, first I have to factor. Now you factor this. I like it, because the middle term's got to be negative, so the bigger one's negative. So now you can see who's missing what. This guy is missing x minus 2 and x plus 1. This guy's missing x plus 1. And this guy's missing x plus 2. Exactly. It's a good point. Some of these problems take long, but they're not hard. Exactly. So then you just have to FOIL this bad boy out. The bottom is going to be all this crap here. FOIL this stuff out here. Right. And then plus x plus 1. And then minus 2x minus 4. The negative's got to come through. This is a good place where you can do this. And then that's really apparent that the negative has to go through. You can see that? And now it's just cleanup. Now you just put together your like terms and see if it'll factor. See if something will cancel out. So x squared minus x plus x is gone, so x squared minus 2x minus 5, I think it is. And that does not look factorable, so that's nice actually, because then I'm done. Is that all right? All right, so let's take a break. Maybe come back at 1:15, and then we'll get into chapter 2. A little more, 15.